Okay, so let's move on. We're going to talk about graphing linear equations. The very first thing I want to do though is make sure we're all on the same page. We're going to talk about the Cartesian coordinate system. And you're like, what's that? So you have up until this point dealt with a single number line, and that was this horizontal number line, correct? Well, now instead of having one number line, we're going to have two. We're going to have the horizontal number line and a vertical number line, but the names of them have changed. The original number line is now going to be known as the x-axis. The new number line is going to be known as the y-axis. By the way, these axes are perpendicular to each other. You're like, what's that mean? And that means they form a 90-degree angle here. With me? Okay, so let's talk about some verbiage. On this x-axis and the y-axis, where they intersect, this is known as the origin. And the origin are those zeros. So like on a number line, the 0 was the middle of the number line, the original number line we spoke about before, and everything to the right of that 0 was positive and everything to the left was negative. Well, since the x-axis is the original number line, the origin is going to be that 0, so to speak. So it is going to have positive to the right of it and negative to the left of it. Now the new number line, which we call the y-axis, right where they intersect is also like the 0 for it. And everything above is going to be positive and everything below will be negative. Are you with me? Okay, now we'll have these things known as ordered pairs. And ordered pairs, pair means two, correct? An ordered pair is made up of not just an x value, but also a y value. Why? Because they have two number lines. And since the x-axis represents the original number line, then x is going to come first. And the new axis, which is vertical, will come second. So that's the y. Are we good? Okay. So before we get too much farther into that, do you notice that these two axes cut this space into 4 regions? These regions are known as quadrants. And the way we label these quadrants is that in the upper right, this would be considered quadrant 1. And then we go counterclockwise from there. And quadrant 2 will be over here. Again, go counterclockwise, go to the left. Quadrant 3, whoops, might help if I made that 3. And yes, I'm using Roman numerals. And then last but not least, quadrant 4. Good? By the way, the labeling of these quadrants also comes up in trigonometry if you're actually heading in that direction. So it's good to kind of be able to relate the two. Okay, so again, these 4 spaces are known as quadrants. Quadrant 1 is in the upper right, and then it goes counterclockwise from there. Good? Okay, now in quadrant 1, I'm noticing that the boundary line for the x-axis is positive and the boundary line for the y-axis is positive, which means in quadrant 1, my ordered pair, both numbers would be positive. Cool? In quadrant 2, I am noticing that the x-axis will be negative here, and yes, sometimes I do call it a boundary mark, and the y-axis will be positive. So any ordered pair in quadrant 2, the first number, which is x, will be negative. The second number, which is y, will be positive. Does that make sense? Okay. In quadrant 3, again, my x-axis is still negative. My y-axis now is negative in quadrant 3. So x coming first, that'll be a negative number, and y will be a negative number. Got it? Okay, and last but not least, in quadrant 4, what do you think? Good. X comes first, and the x-axis is positive, and the y-axis is negative. So any ordered pair in quadrant 1, both numbers would be positive. Any ordered pair in quadrant 2, the negative number comes first, the positive number comes second. In quadrant 3, they're both negative. And in quadrant 4, the first number is positive, the second number is negative. Got it? Okay. Now, we are going to plot some points. Okay? Points is a short name for an ordered pair. So just so you know that. So if they say plot points, well, we're plotting an ordered pair. With me? Okay, so you get your graph going. I'll get my graph going. Just need a moment or two to erase this. And you know what? I understand that some of you have seen this before, and so this might be a refresher for you, and that's good. But for those of you who have not seen that before, make sure that you've got your notebooks out and you're taking some very good notes for yourself, because graphing never goes away in math. Once you learn to graph, you always end up graphing two-dimensionally, shall I say? Because we have an x-axis and a y-axis, so it's kind of like a two-dimensional graph going on. All right? Okay. So, got that situated. Let me make my tick marks here. And then we'll be off and running. Okay. So now, I want to plot some points. And not only do I want to plot some points, I want to know the quadrant they're going to lie in. But let's do first things first. Let's plot the point 2, -3. So remember, the first number represents x and the second number represents y. Got it? And how you start plotting points is this. You always start at the origin. And these numbers are like a set of directions to get you to the resulting point, the resulting ordered pair. So I'm starting at the origin, and the first number representing x tells me to go +2 on the x-axis, which means start at the origin, I'm going to go 2 to the right, because that's positive, correct? My second number says, hey, now on the y direction, I want you to go -3 spaces. So, start at the origin, go 2 to the right, because that's positive. On the y-axis, I need to go in the negative direction, which is down. So from here, I'm going to go down 3 spaces. And so this is the resulting point, 2, -3. Good? Okay, got another one for us. So, again, the first number represents which axis? Good, the x, and the second one is the y. Where do I start? At the origin. And according to these directions, I am supposed to start by going the negative direction on the x-axis 1 space, which means I'm going to start at the origin and go left 1 space, because left is negative for the x's. And then according to the second number, which represents y's, I'm supposed to go +4 spaces. So, start at the origin, left 1 space, and then I'm supposed to go up 4 spaces, because that is the positive direction for the y's, and there is my point -1, 4. With me? Okay, let's look at another one. I want to look at 0, -2. Okay, first number represents what? Yeah, the x's. So according to that number 0, do I move from the origin? Do I go left or right on the x-axis? No, I don't. But I do go which direction? On the y's. Yeah, I go down 3. So I start at the origin, I don't move left or right, and I go down 2 spaces. And so right here is that point 0, -2. Cool? All right, how we doing? Let me throw another one at you. How about -5, -1? Got an idea of what you got to do there? Where do I start? Good, start at the origin and then go which direction? Excellent, left. How many? 5. And then where? Good, down one space. So here is our point, -5, -1. Does that make sense? Okay, so now I want to know the quadrants that these points are lying in. The 2, -3 was this located right here. Which quadrant is this? Remember, first quadrant starts in the upper right, and then how do I label? Counterclockwise. So this is quadrant 1, quadrant 2, quadrant 3, and good. That one was quadrant 4. How about the next point, -1, 4? Yeah, this is quadrant 1. That lies in quadrant 2. Excellent. How about this next point of 0, -2? Some of you are like, I want to skip it. Okay, we'll skip it. We'll come back to it. How about the point -1, -5, -1? Yeah, that is quadrant 3. Okay, back to number 3, because you wanted to skip it. That point is here, isn't it? Is it in a quadrant? Because that was my question. Which quadrant is it in? Is it in a quadrant? Good, it's not. It's on a boundary line, isn't it? It's on an axis, isn't it? So which axis is it on? Good, it's on the y-axis. So that's how I'm going to label the location of that particular point. Cool? Okay, hang in there. Got some more examples for us. Okay, so let's look at this set of directions. They're asking us to determine if the ordered pair is a solution to the equation. Ordered pair is a point, right? And that point consists of an x and a y. And the x is always written first, isn't it? Okay. And this is the equation they gave us. Y equals 3x minus 5. Cool? Okay, so let's look at the first point they gave us. The first point they gave us was 0, 5. So remember, the 0 is actually representing what variable? Good, x. And the 5 is the y. So what do you think you're going to do with these two numbers to decide if these numbers are actually a solution to that equation? Good, I heard you. Plug them in. Because you got to check it, right? And when we check our answers, we plug them in, don't we? Okay, got it. So I'm supposed to write the y first, which in this case is 5. And that's supposed to equal 3 times x. What's my x? 0. And then I'm supposed to subtract 5, correct? Okay, so we have 5 equals, 0 minus 5. What's 0 minus 5? -5. Huh, does 5 equal -5? Yeah, no. So is this point a solution to that equation? Nope, not a solution. Got it. Let's look at problem number 2. Same question, they want to know if it's a solution. So what are we going to do? Yep, we're going to plug it in. So I'm supposed to write the y first. Good, that's your -8. So I'm going to write the -8 first. Equals 3 times x. What's my x? Good, the -1. And then I'm supposed to minus the 5, right? Okay, so what's 3 times -1? Good, -3 minus 5, right? So what's -3 minus 5? Start off the calculators. Good, -8. Wow, well does -8 equal -8? Yes, it does. So is this point, is this ordered pair a solution to that equation? Yes, it is. All right. Good? Makes sense? Okay, so hang in there. We're going to start graphing some equations. Okay, so now we're getting into graphing mode because the directions say graph the linear equations. Got it? Now, when you look at the word linear has what word in it? It has the word line. So it's implying that we're going to have a line when we graph these things. Now, here's the deal. You can tell that these equations are both linear equations without them telling you that. And you're like, well, how do you know? Here's how you know. So make sure you grab pencil or pen in hand and ready to write. Let me ask you a question. What's the exponent on the x? Yes, it's a 1. What's the exponent on the y? It's also a 1. Remember, if you don't see the exponent, it's a 1, correct? Because both x and y have a power of 1, that makes them linear. Got it? Because both x and y have powers of 1, that makes them linear, which means when I graph it, I'm going to get a line. Cool? Okay, loving it. Now, we have 3 different methods of graphing linear equations. I'm going to start with the very basic one, and the very basic one is us making a table. All right? So, we have an XY table here. I put x first because when we graph the x coordinate first, right? And then we graph the y number, right? Okay. Now, here's the deal. How many points make a line? Good, 2. In our world, it's going to be 3 points. Just in case we make an arithmetic error. That's why 3 points is better. So now, when I look at example number 1 or problem number 1, and I'm looking at the equation, I'm noticing that the y variable has all the numbers around it. The x is by itself, which is fine, but the y variable has all the numbers around it, doesn't it? So when we make a table, we get to choose which variable that we want to plug numbers in for. And we get to pick which numbers we want to plug them in for. Because it doesn't matter, since I'm going to end up with a line with all those numbers on it already. So it's my choice what numbers to choose and which variable to plug it in for. Now, me personally, on problem number 1, because y has all the numbers around it, I'm going to plug numbers in for y. And I know some of you have done this before, and you were always taught, get y by itself and plug in for x. And I understand that. But you don't always have to do it that way. Not for when you're making a table. You don't always have to do it that way. Since the y has all the numbers around it, that's the variable I'm going to plug in for. And the numbers I like to plug in are positive numbers, negative number, and then the neutral number. So, I'm going to plug in a positive 1, I'm going to plug in a 0, and I'm going to plug in a negative 1 for the y variable. And now I get to do my work. So some of you, it would be good for you to write your work off over here or wherever. But in order to find the x, you have to do 2 times the y value, don't you? And then minus 4, because that's what it says that you need to do to find x, correct? So it's 2 times 1, 2, minus 4, negative 2. So in this case, my x is equal to a negative 2. So this point is a negative 2 for x and a positive 1 for y. Cool? Okay, so let's look at the second one. To find its x value, I have to do 2 times the y value and minus 4. So it's 2 times 0, 0, minus 4, negative 4. And my x is a negative 4 and my y is a 0. Cool? Okay, one more number. To find that x, I have to do 2 times negative 1 and then minus 4. So 2 times negative 1 is negative 2 minus 4, negative 6. So this point would be negative 6 on x and negative 1 on y. Cool? All right, so let's graph this thing now, shall we? You get your graph paper. I got to make my graph paper. And I'm noticing that put an extra one there. I'm noticing my x's are basically all negative, aren't they? All right, so let's see what this looks like. Again, where do we start? At the origin. According to this first point here, you're going to go 2 to the left and then 1 up. According to the second point, start at the origin, go 4 to the left, and don't go up or down. And then according to this third point, start at the origin, goes 6 to the left and down 1. And when I connect my points, let's see if how well mine connect. Yours might connect a little better than mine. This is the line that represents the equation x equals 2y minus 4. Cool? Awesome. Let's look at problem number 2. On problem number 2, do you notice that x and y are both on the same side? So you can leave it that way if you want, or you can get one of those variables by itself. Just like on problem number 1, they already gave us x by itself. So over here, it's your choice if you want to get one of those variables by itself. I recommend it. Which variable do you think would be the better variable to get alone, to isolate? Some of you said x, some of you said y, some of you are like, I ain't sure. Well, let me ask you this. If you get the x by itself, eventually you have to divide by 3. Agreed? Will everything divide nicely by 3? Nope. Then I ain't getting the x by itself. I don't want to deal with fractions. The y. To get the y by itself, do I have to divide by anything? Nope, I don't. Which means I'm getting the y by itself. And to get the y by itself, you're going to have to get rid of this 3x, right? By doing subtraction. Good. So I have to subtract that from both sides, don't I? Which means I end up with the equation y equals 5 minus 3x. Does that make sense? Okay. And now I get to make a table. And in this case, which variable do we plug numbers in for? We plug them in for x because x has all the numbers around it. And again, I like my positive number, my neutral number, and my negative number. You got to see what's happening in all three ends of the world, so to speak. Good? Okay, so I'm plugging in 1 for the x. So to find the y value, according to your equation, you have to do 5 minus 3 times 1. Well, what's 3 times 1? 3. What's 5 minus 3? Good. 2. Which means we have the point 1, 2, don't we? Let's go for the next one. The next one says to find the y, you're going to have to do 5 minus 3 times x. Well, my x in this case is 0. So this will give you, good, 5. Which means you end up with the point 0, 5. Good? Okay, one more number to plug in for x. 5 minus 3 times negative 1. Now some of you may want to do the work on this because you're a very visual person. So you're going to do 5 minus, negative 3, which is actually 5 plus 3, which is 8. So in this case, we have the point negative 1 comma 8. Good? Okay, so let's see what the graph of this equation looks like. My first point was 1, 2, wasn't it? So start at the origin, go which direction? 1 right, and then 2 up. Good. The next point is 0, 5. Start at the origin. Good. Don't go left or right because that x is a 0. And then go 5 up. So here is that second point. Lastly, negative 1, 8. Start at the origin. Good. 1 to the left and 8 up. Uh-oh. This guy isn't tall enough. Hold on. I need to get a couple more tick marks in there. Okay, so when I do that, I end up here. And when I connect these dots, hopefully your line looks a little better than mine. Mine kind of squiggled. But this line represents your equation 3x plus y equaling 5. Does this make sense? Yeah, tables are really nice. They're really easy to work with. Okay, hang in there. Got a couple more examples of graphing for us. Okay, so let's look at this third example. This third example is asking us to graph this equation y equals -4. So let me ask you something. Is this a linear equation? Yes, it is, because the power on the y is a 1. So that is definitely a linear equation. And the way we're going to graph it is we're going to graph it using a table. So let's make a table. I have x and y. Now, here's the thing. Do you see any x's in here? I don't either. So here's what I'd like you to do. I'd like you just to watch for a moment. Bear with me, because I want to show you something. So I'm going to choose to plug numbers in for x. And you're like, I don't see an x. I get that. So bear with me still. I'm going to plug in my normal numbers for x. A 1, a 0, and a -1. All right? So here's the deal. If I plug into this equation the number 1 for the x, according to this equation, what's y going to equal? Yeah, this equation says y equals -4. So there it is. When I plug in 0 for x, I know there's no x in here, but according to this, when I plug in 0, what's y going to equal? Yeah, this equation says y equals -4. What about that last number for x? Yeah, the equation says y equals -4. So my question is, for this number 3, for this third equation, does it matter what x equals? No, x could be any number I wanted. This equation says no matter what x is, y will always be a -4, which means I'm going to write them down here. I've got the point 1, -4. I've got the point 0, -4. And then I've got the point -1, -4. It doesn't matter what x is for this equation, y is always going to equal -4. So when I plot these points, I go, start at the origin, very good, 1 space to the right, and then 4 down, don't I? The second point, start at the origin, good, don't go left or right, correct? Just go 4 down. Got it. What about this third point? Good, start at the origin, go 1 left and 4 down. And when I do this, I end up with a horizontal line, don't I? And the horizontal line passes through the y-axis, and it passes through the number -4. Got it? This is the equation y equals -4. This equation, the graph of this equation does not pass through the x-axis because there was no x in there. It only passes through the y-axis. Got it? Equations 1 and 2 that we did a few moments ago, they had x and y in there, so they passed through the x and the y-axis. Got it? Okay, let's look at this fourth one. Again, yep, we're going to make a table. Now, according to this equation, what is x? It's linear because the power is 1. But according to this equation, x equals what? Yeah, x equals 3. Can x be any other number in this equation? No, according to this equation, x is always 3. So does it matter what y is? Nope. Y could be +1, 0, -1. It could be 10. It could be 100. It could be -30. Y could be any number in this case. So we have the point 3, 1, 3, 0, and then 3, -1. So when we plot these 3 points, start at the origin. Good, 3 units right, and then 1 up. That's how we get the first point. The second point, start at the origin, 3 units right. Don't go up or down because that's a 0. And the last one, 3 units to the right and 1 down. And so in this case, I get a line passing through the x-axis only, and it passes through the number 3 on the x-axis. There's no y in here, is there? So this vertical line does not pass through the y-axis. It only passes through the x-axis. Cool? By the way, the first two problems we did on graphing, they had x and y, so they passed through x and y, didn't they? The x and y axis. That only works for linear equations. Don't try to apply it to anything else. So if you're graphing a linear equation and there's x and y in it, like the first two examples we did a few minutes ago, then it's going to pass through the x and the y-axis. If it's a linear equation and all it has is y in it, it's only going to pass through the y-axis. If it's a linear equation and all it has is x in it, it's only going to pass through the x-axis. Does this make sense? Cool. Okay. You have fun with this stuff, and I'll catch you on the flip side.